We're going to look at number 34 next. So if I focus in on number 34 right here, we're starting out with, on the top of this monomial, 3x y to the negative first, and then on the bottom of the monomial, negative 4x to the negative second. Remember, you cannot have negative exponents. So to do them, you move them to the rule is you move them to the opposite part of the fraction. So what we're going to do is we're going to take this x to the negative second. That's got to get moved up. So we're going to have x to the second on the top. The y to the negative first is going to get moved down and become y to the positive first on the bottom. Okay, now remember, I still have this 3x on the top, which was right here, 3 and x. Okay, again, that negative 1 exponent was only on the y up top. And then on the bottom, I still have this negative 4 that was right here. Okay, now we got to simplify a little bit. We can do the multiplication of x times x squared on the top. Remember, that's x to the first, so I'm going to get 3x cubed, add the exponents, all over negative 4y. We can't do any more simplifying. You could put the negative out in front of the whole fraction, but we'll leave it down on the bottom. Okay, then we're going to go down and we're going to talk about in section 1b, we're going to talk about scientific notation. Scientific notation, when you write numbers in scientific notation, okay, you're going to have a number times 10 to some power. So you'll have a number out in front, decimals, and usually some digits after the decimal. The rule on this number out in front is that it's got to be between 1 and 10. And the exponents can be positive or negative, and it's okay in scientific notation to have negative exponents. So we're going to look at 41 here. I have 569. Now the decimal point is after the 9. Okay, we're going to write it in scientific notation, so I'm actually going to move it 2 places to the left. I'm going to write it as 5.69. So any non-zero digits you need to keep. Okay, and then it's times 10, and we got to figure out the power up here. Okay, if it's a number bigger than 1, and we use scientific notation when numbers are bigger than 1 or smaller or a decimal between 0 and 1. If they're a decimal between 0 and 1, the exponent's going to be negative. If they're bigger than 1, the exponent's going to be positive. In this case, I moved it again 2 places, so it's going to be times 10 to the second power. So it's 5.69 times 10 to the second power. Okay, let's go down. Now we're going to get to some operations. Okay, in scientific notation, you do not have to convert these to regular numbers. The rule, and we'll do number 47 here. I'm going to make my marker a little bit thinner. We'll do number 47. And when I multiply two numbers in scientific notation, the rule is this. You multiply the things out in front. So if I take my calculator, or you take your calculator, you're going to take 1.9 and you're going to multiply it by 7.39, and I get 14.041. Okay, and then it's going to be times 10 to the power, and then what I do with those is I have 10 to the third times 10 to the fifth. So imagine multiplying 10 to the third times 10 to the fifth. The rule is you add the exponents, so that'll be 10 to the eighth. So this exponent up here is going to be 8. Now, it looks like that number's in scientific notation, but we have one issue with it. This number out in front right here is not between 1 and 10, and that's the rule in scientific notation. So you got to do some adjusting of your exponent, or of your decimal and your exponent. So I'm going to take this decimal point, move it over. It's 1.4 and then 0.41. Okay, so we're making it between 1 and 10. Now here's the rule. You've got to adjust the exponent by 1, and the rule is this. If the number part got smaller, so in other words, I went from 14 down to 1 something, that got smaller, then the exponent gets bigger by that 1. So it'd be 10 to the 9th. And it's the opposite way. If you made the number part bigger, to get it between 1 and 10, the exponent gets smaller.